Let's talk a little bit, because I asked you to do this, on snow removal. One of the advantages with the radiant heat system is that you can put it out in your driveway, on your sidewalks, and you can put it in your roof, and you can use it as a means of snow removal, which in a place like Watertown, New York, is probably not the worst thought in the world. It's expensive, but and you see this more in commercial than residential, but it is there, and because again, snow removal is expensive. There's also safety issues. If you're a business and people are coming in and they slip and fall on your icy driveway, you're legally liable. So you may want to not have that happen. So anything that's done outside is almost certainly a concrete system. You're getting 35 to 40 BTU per hour kind of output per square foot. You're using a 6 to 9 inch spacing, and you're going with 500-foot loops because you're using 3/4 inch PEX. So outdoor systems tend to be bigger. You use the bigger PEX. A concrete system, something like this, you've got your basic slab installation down below. You put in insulating layer to drive the heat from these pipes upwards, and you put an overpour 3/4 inch to an inch above the pipes. This is an expensive way to go, but again, if you're in an area with a lot of snow and you just don't want to pay people to move the snow around, this is a way to get around it. There are other systems. There's heat pipes that work very well, which are two-phase flow devices. They were the rage back in the 1980s when I was working at IBM. We tried to use heat pipes for everything in cooling. The Japanese use them to do automatic snow removal in mountain passes, and they work very, very well, because unlike this, you're not pumping hot water through them. The heat pipe is closed on both ends, and you're using partial pressure. When it gets cold enough on the surface, because there's an indication of snow there, or it's just plain darn cold, you use the heat of the earth, the geothermal, and you're going from about 0 degrees to 50 degrees down below, and it starts the heat pump flowing, working, and it gets the glycol inside boiling, and it pumps the heat up to the surface and removes the snow. And the beauty of the heat pipe is, once the snow is removed and it warms up a little bit on the concrete, the heat pump stops working. So it only works when it needs to. It's a very clever system, but hideously expensive, but doesn't require any pumps. Roof systems for the hydronic, very similar. Obviously no concrete. We use the PEX with the metal plates. We get about 30 to 35. Again, that's about all you're going to get. You don't get it. It's not as nice as the concrete, which spreads things out. Generally 6 to 9 inch spacing, 500-foot loops, 3/4 inch PEX is the general rule. And we said for Watertown, the average is 102 inches of snow per season on a system like this. So there's enough snow there that putting it up on the roof may be a useful thing. And that's what I ask you to do, is look at the roof. We used a very simple calculation for it, so it should be pretty straightforward, I hope. One of the issues you have, though, with the snow removal, because you're in the outdoors, water isn't going to work. There's too great a danger of freezing. So what you have to use is you have to use glycol. And glycol doesn't transfer heat as well as water. Water transfers 1 BTU per pound per degree F. Glycol only transfers 0.84 BTU, so it's 16% less efficient than water for heat transfer, but it's still pretty good. And we have no choice but to use it. How much do you need? Depends upon how cold it is. Glycol is more viscous, so you need larger pumps and pipe diameters. That's why we use the 3/4 inch. Glycol, by more viscous, I mean It sticks more to the walls. It doesn't flow as freely as water does. Think of something like motor oil. Motor oil is very viscous. Glycol is not as viscous as motor oil, but it's more viscous than water, so it takes more energy to pump it through a pipe, and that's always an issue. So it does need to be its own loop, right? This snow removal will be its own zone, because you can't have the glycol mixing with the water in the rest of the boiler system. So it needs its own sub loop. Amount of glycol based on the low temperature outdoors. So what we do, we say Watertown, it's about -10 outside. That's about the low temperature. So you separately zone this. You have a glycol tank installed in the basement. This is explained in one of the videos fairly nicely. You'll see it when you watch those other YouTube videos. And we can see that for a -10 system, by weight and volume, we need about 42% of it glycol. So a 6-to-4 mixture of glycol and water, 6 parts water, 4 parts glycol, would properly take care of our problem in Watertown. So, this is how you would set this up. So this is only for one particular fluid I found off this one website, but close enough. Okay, the last bit I want to do before we close up is look at the hydronic pages in the handout. And you can see again, what am I asking for? Feet of pipe per room. You know how to calculate that now. And I added space for the closet so you can toss that in. If you want to throw it in the room and not use this box, that's fine. But I do want to see total feet of pipe for the floor, because I'll tell you how many loops you want. You can make a decision, gee, do I put the bedroom and bathroom on, its own zone? Yeah, that might make sense, and then keep the rest of the place on another zone. That's not a bad idea. And you can look at doing that, because you're only going to need a loop for this. One loop will cover this area here, and then the other couple loops will handle this. And then again for the upper floor, same thing. Do you want these separately zoned? I don't know if you need to. You certainly can. When we say 300-foot loops, you can have less, so there's no problem there. And then, fill in where'd you find the boiler, what's the website, gallon per minute of flow of the boiler. The neat thing is, when I asked for how much gallons per minute of flow for the hot water and the rooms, should be the same. These two numbers should be identical. That's kind of a misleading thing, but, again, just, I want you to prove that to yourself. Then I want you to throw the roof in. So you're going to use the 3/4 inch pipe. That is going to increase your flow rate a bit. You might need a bigger system to handle it, depending upon what you select. The area of the roof calculation, I'm assuming that a lot of us haven't been in 10th grade geometry for a long, long time. So if it's okay by you, I gave you the formula for that. You just take the width of the house, which is our 29.4, divide it by the cosine of 20. So let's say 29.5. Let's not be crazy. 29.5 feet divided by the cosine of 20 is, 29.5 divided by 20 cosine is 31.4 times the length of the house times 38. So roughly you have 1,200 square foot of roof. Okay, so 1,200 square feet of roof, and then you would multiply that for the 3/4 inch PEX numbers and calculate the number and spacing on 9 inches, and you will get the number of feet for your snow removal. And that should take care of it. So let's go ahead and do that, and you'll be good to go.